Scientific notation can be used to describe very large numbers and very small numbers. To write a number in scientific notation in the correct form, we need to start with a one-digit number that's between 1 and 9, and that's including 1 and including 9. Then we'll have the decimal point. All numbers that don't end in 0 will multiply by 10 raised to an exponent. That exponent will be positive if the number is big and negative if the number is small. So if we look at our following examples, we're going to write our answers either in standard notation, the numbers the way we're used to seeing them, or scientific notation. So if we look at this first example, we have 12,300,000. In any number, the original decimal point is at the end if it's not written anywhere. So this is our old decimal point. I need to figure out where I'm going to move the decimal point to. I need to have that decimal point so that there is one digit that's 1 through 9 in front of it. So that's telling me that I want my new decimal point to be in between the 1 and the 2. Then I'm going to move from the new decimal point to the old decimal point. I need to go 1, 2. Let's start over. 1, 2, 3, 4, 5, 6, 7 spaces to the right. So if I'm writing my answer in scientific notation, I'll have 1 followed by the decimal point, 2, 3. I drop all the zeros, times 10 to the power of 7. Right, this number was large, so my exponent has to be positive. And I can also think of it because I went from the new decimal point to the old decimal point. I went right. That's another way to know that that exponent needs to be positive. Now, if I look at this next example, where I have 3.48 times 10 to the 6th power. This 6 is telling me to move the decimal point 6 places to the right. Because it's positive, it's telling me to go to the right. So I have 3.48. I need to go 1, 2, 3, 4, 5, 6 spaces to the right. I fill in those blank spaces with zeros. So I have 3,480,000. If we look at the next example, we have a small number, 0.00003256. So in this number, we have the old decimal point already. I need to figure out where to put the new decimal point. I need to put it in between the 3 and the 2 so that there's one digit that's 1 through 9 in front of it, and everything else is after it. Then I move from my new decimal point to my old decimal point. So I go 1, 2, 3, 4, 5 spaces to the left. For the number part out in front, I'm going to have 3.256. I drop all those zeros in front of the 3 times 10. And then because I had to move 5 spaces to the left, I have to the power of -5. I also know that that exponent needs to be negative because the number is small. If I look at the next example, I have 6.9 times 10 to the -6th power. That -6th power is telling me to move the decimal point 6 spaces to the left. So I have 6.9. I need to go 1, 2, 3, 4, 5, 6 spaces to the left, and I fill in all those blank spaces with zeros. So I'm going to have 0 point, and then I have 5 zeros, 6, 9 for my answer in standard notation. We can also look at some numbers that aren't quite in scientific notation, even though they look like they are, and figure out how to get them into correct scientific notation. So if we look at this first example, we have 52.5 times 10 to the 5th power. The issue here is that this 52.5 is too big. Remember that form for scientific notation, we can only have one digit between 1 and 9 in front of that decimal point. So I really want to have 5.25 times 10 to the something to get this in scientific notation. Because I'm moving that decimal point one space to the left, I need to add 1 to that exponent of 5, which gives me 5.25 times 10 to the 6th power. To help kind of make sense of it, let's pretend this number, 52.5 times 10 to the 5th, actually was in scientific notation. I know that 10 to the 5th is telling me to move that decimal point 5 spaces to the right. So I'd go 1, 2, 3, 4, 5. So in standard notation, I have this number. But I want to get this in scientific notation. So I know my old decimal point is at the end of the number, and my new decimal point should be between that 5 and that 2. So there's only one digit, that's 1 through 9, in front of it. That tells me I need to go 1, 2, 3, 4, 5, 6 spaces to the right, which gives me the same answer here. So if we look at another example, we have 13.8 times 10 to the negative 6th. I have the same issue that 13.8 is too big. So I'm going to put my decimal point in between the 1 and the 3. And because I bumped that decimal point one space to the left, I need to add 1 to that exponent, just like I did in the last example. So that gives me 1.38 times 10 to the negative 5th power. Now, if we look at the following two examples, we have the opposite problem. This number out in front of, at the beginning of our scientific notation, the 0.25, is too small, right? That digit in front of our decimal point has to be 1 through 9. So what that's telling me is I need to think about putting that decimal point in between the 2 and the 5. I'm moving the decimal point to the right. So if I do that, I'm going to have 2.5 times 10, and then to figure out my exponent, I need to subtract 1. So I end up with 2.5 times 10 to the 8th power. Just like before, we can write this out to help us figure out what's going on. If I had that 0.25 to the 9th power, I need to go 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces to the right. So I have 25 with 7 zeros after it. If I'm trying to write this number in scientific notation, the old decimal point is at the end of this number. The new decimal point needs to be between that 2 and that 5. So I go 1, 2, 3, 4, 5, 6, 7, 8 spaces to the right, which gives me that 2.5 times 10 to the 8th power. If I look at this next example to make sure I understand it, I still have that first part of the number, that scientific notation is too small. It's 0.5678. So I need to rewrite it as 5.678. Because I bumped that decimal point to the right, I need to subtract 1 from that exponent, which is going to give me 5.678 times 10 to the negative 6th power. Now we can also perform operations with scientific notation. We're going to focus on multiplication and division. So if we're multiplying two numbers that are in scientific notation, we're going to multiply the numbers before the multiplication sign together. We write our 10 times, we add the exponents, and then we double check that it's in the correct form. If it's not, we fix it. So if we look at this example, we have 7.1 times 10 to the negative 7th power times 8.3 times 10 to the negative 5th power. So I'm going to multiply those whole numbers first, 7.1 times 8.3, not necessarily the whole numbers, but the numbers out in front. And then I'm going to group together the exponents, that 10 to the negative 7th power times 10 to the negative 5th power. When I multiply the number parts, 7.1 times 8.3, I get 58.93 times, then when I multiply powers with the same base, the base 10 stays the same, and I add the exponents. Negative 7 plus negative 5 gives me negative 12. Now this is not in the correct form. That 58.93 is too big. So if I look back up, when we had numbers that were too big, we bumped the decimal point over and we added 1 to the exponent. So I'm going to bump that decimal point over and say that it's really 5.893 times 10, and then I need to take that exponent negative 12 and add 1 to it. So I have 5.893 times 10 to the negative 11th power for my final answer. When we're dividing numbers in scientific notation, we do pretty much the same thing, where we're going to divide those numbers before the multiplication sign first. So we're going to deal with the 8.5 divided by 3.4. We write our 10 times. We subtract our exponents using those exponent rules. When we divide, we subtract our exponents, and then we make sure our answer's in the correct form. So if we have 8.5 divided by 3.4, that gives me 2.5 times 10. When I divide my exponents, I subtract them. So I have 8 minus negative 5. I know when I'm subtracting a negative, I'm really adding a positive. So for my final answer, I'll have 2.5 times 10 to the 13th power.